Welcome to Chuck Builds. Today, we are going to be creating the LED matrix that you see on the screen. This is a project I've been working on for the last few months, but I've had a version of this LED matrix in my office for the last 5 or so years. I really enjoy having this, and it's a great way to see information at a glance, including sports scores, and you can create your own for about $100. We're going to be getting most of our parts from ADAFruit, and that is a Raspberry Pi, 2 RGB LED matrices. We have an ADAFruit RGB bonnet and power cord. The software is written by me, and it's going to be a work in progress for a while, but I'm at a spot where I think it's good to share. This display has many sports such as NHL, NBA, MLB, NFL, NCAA football, basketball, and baseball, and soccer for various leagues. We've got a now playing music display that supports Spotify and YouTube Music. We've got stock tickers, crypto tickers, stock news that scrolls by, a Google Calendar integration, and a YouTube subscriber and view count. I hope to continue adding features as this project matures, but I'm really excited to share this. I've worked very hard, and it's in a spot that I think anyone can set this up in less than an hour and have a great result. I've tried my best for the write-up on chuck-builds.com and GitHub to capture everything you could possibly need to make sure that you can get this set up with no experience at all. I'm really excited to share this with you, and I can't wait to hear what you think. So buckle up if you want to make this yourself. There is quite a lot to cover in this video, and I'm here to assist you if you need help on Discord or on GitHub issues. You can raise a ticket. Thanks so much for watching, and I hope you enjoy. There's not a whole lot of components that make this up, and I'm going to go through this very quickly with a partial assembly of what we have here. This is a Raspberry Pi 3B. I think it's 1 gigabyte of RAM. I kind of wish I had a Raspberry Pi 4 for this with 4 gigabytes, just because I think it'd be a little bit smoother, faster, and easier to process on the display, but this does work. And all we have here is a micro SD card that we will have our software on. I have a 16 gigabyte one. I don't think we're anywhere close to using all of that, but the price difference from 8 to 16 is like nothing nowadays. So, and to install that on your Raspberry Pi, you just click it in right there. So next up, what we need is the ADAFruit RGB matrix bonnet for Raspberry Pi. We do have a bit of a hardware mod here where we have soldered pins 4 and 18 together. This is a PWM flicker fix for this specific bonnet. This has worked great for me so far. I would highly recommend it, and I highly recommend doing this mod here. It's very easy, even if you can't solder very well. That will help us get less flicker and more brightness on the LED matrix. So to put these two pieces together, you're going to take your bonnet and your Raspberry Pi, and you're just going to mate them together through these holes on the GPIO ports. Make sure that you don't skip any of the holes, and then you just pinch it together with a slow, steady press. It'll go together and have a nice connection there. I try to leave a little bit of airflow underneath, but it's not a big deal if it sags. We've got 3 ports. We have a power in for the display and the Raspberry Pi, so we don't have to use a USB power port. We have the power out for the LED, and then data for the LED. And before we set that up, I should probably show you the LED display we're using. I have 2 64 by 32 pixel RGB matrices from ADAFruit. These are specifically 4 millimeter pixel pitch, which is the gap between the pixels. I initially had, I think, the 2.5, and it makes the whole screen smaller. It just brings everything closer in. And that's better if you're going to be viewing it from a very close distance, like on your desk. But if you're going to view it from across the room, you're going to want more pixel pitch. That makes it just larger and brighter and easier to kind of see from a distance. But if you want to do it how I'm using it, I would highly recommend the 4 millimeter pixel pitch. Also, because these 3D printed stands are specific to the 4 millimeter pixel pitch. because the whole screen changes, or the whole matrix changes size based on that pitch. I also want to make sure I mention that my software for this LED matrix was primarily built with 2 displays in mind. 2 displays or more is better. It'll only get bigger with more, but anything smaller, like a single display, there's just not a lot of pixels here. There's not a lot of space to make text, to make images. Even the smallest font that you can run on some of these to make it legible is going to chew up a large amount of space. And having just a little bit more space here makes a huge difference. However, with the design of this is what I had. So this is what I wrote it for. And I tried to make it dynamic so you can try other sizes, but really so far, I'd plan on sticking to the 64 wide by 32 tall pixels with 2 of them, and all they are is sitting next to each other and screwed in here. The stand keeps them upright, but you can't see that well from this angle. And let's get this thing kind of wired up. It's very, very easy. You take your Raspberry Pi, and we're going to plug in our little connector here. It does have a key. You can only go one way with this little bump. So plug your bump in here, and then we're going to attach that to this very first port on the end here. Note the arrows here that this is going to broadcast out in this direction. That is because we can daisy chain this with the other connector that came with the second display and just piece these together here. So now the data comes from the Raspberry Pi into this screen and then goes across that way. And it's very easy to tell which number of pixels you have. But with the arrows, it can really only go one way. We have our power cables. And I can't remember if I made it this way or if it came like this. I kind of feel like it came like this because it's been years and this is pretty clean work for me. But you're going to take these clips and just clip them in where it says power. It just says power right there. And so you'll take your clips and clip them in. And we can tell from the text on our board that we have VCC and ground, red and black. And so we want to make sure we respect that ground when we go to plug it in to our Raspberry Pi. We have 2 receptacles here to put in our power, and they are labeled with 5 volt on the left, which would be red, and then our negative on the right, which will be black. So I'm just going to slide these in. Once you have your Raspberry Pi put together with the ADAFruit Bonnet, we've got our power for the displays, we have the data for the displays. We'll take our DC adapter for the power and plug it in. And you can see that we get some lights as it turns on. And once you configure the Raspberry Pi with my script from GitHub and we set up the Autostart systemd script that will run the display when power is applied, you'll see that the display comes on automatically, which it should do in just a moment. All right, we're now going to start with the software side of setting up the Raspberry Pi LEDMatrix. I'm going to be strongly leaning on my write-up at chuck-builds.com, but it's almost identical on the GitHub. We're going to take a micro SD card and plug that into the PC, and we'll be scrolling down on the write-up. We've already done the hardware portion, and we're going to get down to preparing the Raspberry Pi. We're going to run the Raspberry Pi Imager. If you don't already have that, you can click this link here to install it, but I do have it. And we're going to just very closely follow these instructions. Choose our device. I'm running on a Raspberry Pi 3. I would recommend the 4. Do not do it on a 5 because the software library is not supported on the Raspberry 5. Raspberry Pi 2 could work, but it might be a little slow. The zeros are just not quite strong enough. For the operating system, we're going to choose an OS. We're going to go to Other. and we'll choose Raspberry Pi OS Lite 64-bit. And then for storage, we'll choose our SD card, our micro SD card. I'm using 16 gigabytes. That's what I had laying around. I think anything more than 8 gigabytes will be good. Less than 8 is probably a little too small, but it's not too picky on size. We'll click next and get some edit settings here. We're going to want to set a host name. This is how we're going to log in and access the Raspberry Pi. And I'd recommend making these match. I'm using LEDPi, and that's going to simplify things later. Set a password, but don't forget it. You're going to need this later. Set up your wireless LAN or your Wi-Fi. This is your SSID, your Wi-Fi name, and Wi-Fi password. And then set your time zone. Before we're done here, we're going to go to the Services tab and enable SSH. And I like using password authentication because it's just a little simpler than setting up key authorization. We'll click Save and then click Yes to overwrite our micro SD card. So the write was successful, and we're now going to go put that micro SD card into the Raspberry Pi. So once the Raspberry Pi turns on, we're going to open PowerShell on Windows to connect to it. We can type ping LEDPi to make sure it's on the network, and we got a response, so it's connected to our internet and doing fine. So we'll do SSH LEDPi, which is our username, at LEDPi, which was our host name. We'll agree to the fingerprint and then say our password. And we're connected. We'll go to the written guide and start pasting commands. This first one is sudo apt update and upgrade. This updates the software on the Raspberry Pi. Think of it like an operating system update. Once that's complete, we'll copy this next line, which installs some specific software, mostly Python related, and Git. And once that's done, we're going to git clone the repository of our GitHub project. And what that does is it essentially downloads the folder of the GitHub project to the Raspberry Pi so that we can access all of these files here. It'll be in the LEDMatrix directory, and we'll have all of these files in there, and it's downloading them for us now. Once that's done, we're going to change our directory to open that folder. If you type ls, you can see that the folder's there, LEDMatrix. So we'll cd into that folder, and we can see the contents of that folder. Next up, we need to install some dependencies and requirements from our requirements text. So we're going to copy this for a sudo pip3 install, and we're using the -- break system packages, so we don't have to use a virtual environment. It just really complicated things. This is only going to be running the LEDMatrix, so we're not worried about breaking installs for other applications because we're only running one application. So now that we've downloaded some of our dependencies, we need to continue on our process and install the RPi RGB LEDMatrix. So we're going to cd into that folder. And once we're in there, we're going to run sudo make build Python. And once that's finished building, we're going to change our directory again to the binding/Python. And then we're going to run the install, the setup Python. We're going to get an error or a warning, but we can ignore that for now and just let it run. And once that's done, we can run this little command here to test it. And it says success. So we have successfully installed the RGBMatrix Python library. So we'll back out a little bit. Back to LEDMatrix, and we've got a few things we need to do. The next few steps are going to be for performance, and one of them is going to be uninstalling unnecessary software or packages that we're not using. I got this from the RPi RGB LEDMatrix documentation that they recommended it, especially on slower or older Raspberry Pis, such as my Raspberry Pi 3. So we'll go through and uninstall those. Y to continue. And once that's done, we are going to blacklist the sound module. The sound module apparently can cause issues with the rapid refresh of the LEDMatrix. So we're just going to copy this whole text and press enter, and it's going to read it back to us. Blacklist sound module BCM 2835. And then we need to update that into the RAM initialization when the Raspberry Pi first turns on. with this next command. And once that's done, we're going to sudo reboot, allow the Raspberry Pi to restart, process those changes. We'll give it a moment before reconnecting. So once it's restarted, we will SSH again into LEDPi at LEDPi, type our password, and we're going to continue with our performance tweaks. The first is we're going to edit the boot firmware command line text. And we're going to go to the end of the line, paste isol CPUs equals 3, Control X to exit, Y to save, Enter to confirm. And we'll do the same with our boot firmware config text. We're going to come down, sudo nano, and then we're going to come to DT param audio equals off. Control X to save, Y enter to confirm. And once that's done, we're going to sudo reboot one more time. And now that it's back, we're going to SSH LEDPi at LEDPi, type our password, and now we're into the configuration section. So whenever we are editing LEDMatrix, we want to CD LEDM tab to autofill and then enter to enter that folder. You can see our folders here and our files here. Next up, we need to create our config template for our secrets. So we have a command right here we're going to run, and that's going to copy a file in our config folder, the config secrets template, and just rename it essentially to config secrets, so that then we can come in and edit these secrets. These secrets are how you're going to set up the API keys for your OpenWeatherMap, for your YouTube channel, and for your Spotify client. For OpenWeatherMap, you go to API, you sign in, you go to API keys, and put in here, LEDPi, click generate, and it's going to put it here. So you'll just take this key and copy it into this spot. You go to the Google Cloud Console, you create a project, you get the YouTube data, then you can get your API key. We'll go to APIs, enable API. You're just going to search for YouTube, data v3. Then you would click enable. For me, it's going to be manage. Come over to credentials. And then you're going to have an API here, and you can click show key to grab that info. And then you'd paste the API key here. So for the YouTube channel ID, you're going to come to your YouTube channel, and then you're going to click on more to get your description and links and all of that. And you're going to scroll down to share channel and then copy channel ID. And you just type that in right here. So for the Spotify music integration, you're going to go to developer.spotify.com. You're going to log in. It'll take you to this dashboard. You're going to create an app, and we'll call it LEDPi. And then for me, this is my second one. App description is Spotify music on LEDPi matrix. The website doesn't matter, but the redirect URI needs to be exactly what we have here. So I'm going to just copy it exactly. Even if it's not correct, if you think this won't work for you, please just try it as is. Then say you understand and save. Once you do that, you'll get a client ID that you'll paste up here. You'll click here to get your client secret that you'll paste right below it. And then once you have this config secrets JSON created, you'll hit Control X to exit, Y to save, Enter to confirm, and that'll keep everything in place. All right, and so now that we have finished updating our config secrets, we can get started with setting up the Spotify authentication. We'll do YouTube Music next, but once you have the secret and client ID here and the URI here, what we're going to do is copy and paste this command for sudo python3 src, which is the folder, authenticate spotify.python, and it's going to pull up a URL. We're going to open this URL, control click agree, And then we get a site cannot be reached error, which is fine. That's expected. Copy your entire URL, paste it here, and then press enter. So we can see that the token information is cached, it was successful, and the process was finished. The last thing we need to do is make the file, the Spotify auth JSON, readable by everyone. We made it with sudo, which is root, and so by default, only root can see it. We don't run part of the script, can't see that. So we're gonna run this command to make that file readable. Now, when we run the display controller application and we get to the music side and we have Spotify enabled in our config JSON, it should pull right up. Moving on to YouTube Music, what you're going to do is open your YouTube Music desktop app, go to the little gear icon, integrations, and enable the companion authorization server. And then we're going to run Python 3 src/authenticate ytm.py. Note this time without sudo. See that it's pulling my local IP address of my desktop computer. And then inside of YouTube Music, we have an auth request that we'll click allow. And that's it. It's finished and it saves the token. So now we're setting up the Google Calendar. The first thing we're going to do is go to Google Cloud Console. And then you're going to come to the navigation menu, APIs and services. And then we'll go to library. And you can either search for calendar or click it right here. Then we're going to click on Manage, and then Credentials, and we're going to create credentials. OAuth client ID, application type is going to be TV and limited input device, and we'll call this LED Pi, and click Create. And then we want to download this JSON right here. So we'll download that. So in our SSH, we are going to type sudo nano credentials.json. This is going to create a file for us to paste the data into. It's the easiest way to get it copied over. We're going to open our JSON. We're going to select it all here. And then let's format our selection. We're going to copy that, paste it, Control X to save, Y, and then enter. And then once we have that, we're going to come back through and type Python calendar registration.py. We're going to go to this link on Google for a device and then enter our code and hit continue and then choose your account. And just kind of keep clicking through continue. And then our credentials successfully saved here. And now if we type ls, we're going to have a token.pickle, and that's used to save your credentials for the Google Calendar. And I'm not going to change too much, but I want to give you a quick rundown of what we need to change. You need to change your time zone. You need to change your city, state, and country. These are needed for the time of the clock, the time of all the games, and the city, state, country is for your weather. The display section is the hardware for your LED matrix. We are using a LED matrix with 32 rows and 64 columns, and we have 2 of them, so our chain length is 2. We only have 1 string of them, so parallel is 1. I have brightness at 95%. You can knock it lower if it's too bright or if it's flickering for you. If you're on a Raspberry Pi 2, you might want to lower this brightness if it's struggling to keep up. Hardware mapping is ADAFruit HAT PWM, and this references our jumper pin here from 4 to 18 with our PWM hardware mod. I highly recommend doing this. It helps a ton with the flicker. The rest of these display settings, we don't need to worry about too much. The PWM, bits, scan mode, dither bits, nanoseconds, LSB, all that junk. It's just what was recommended, and it's what's working for me. If you really know what you're doing or you are Googling it, you can change these to work better in your scenario. But I would start here because it's been working great for me on this hardware. Refresh rate, I've got at 120. It's clear. I think the RGB LED matrix from H. Zeller, they recommend 180, but I couldn't really tell a difference after 120, and it just ran smoother at 120 for me. The text scrolling is still clear, but it doesn't flicker as bad as a higher refresh rate. Runtime depends on your Raspberry Pi. I think the rule of thumb is if you're on a Raspberry Pi 3, you put 3. If you're on a Raspberry Pi 4, you put 4. If you're on a Raspberry Pi 2, you put 2. What this does is it slows down the Raspberry Pi to not overload the hat through the GPIO pins, and it just kind of slows everything down so that it can be read correctly and reduce some of the flicker. Display durations control how long each display module stays on the screen. You can tune these based on your preferences. Clock is 15 seconds, weather is 15 seconds, stocks is 30 seconds. You can change all of these. The only caveat is going to be with the live sports. When a sport is live, it stays on the screen for as long as the game is active. The live duration, display duration, is rotating between multiple sports and multiple teams. If the Dallas Stars and the Texas Rangers are playing at the same time, it'll show me the hockey for 30 seconds, and then after 30 seconds, it rotates to the next live sport, which would be MLB, which I also have configured for 30 seconds. If you want it to be quicker, you can shorten it. If you want it to be longer, you can add more time. Again, it's in seconds. It really depends on how many favorite teams you have and how many seasons are active at the same time with overlapping games. 30 seconds I find is nice, that I can look, see a change, and get back to what I'm doing and know the score. Over a minute, you're kind of waiting a long time for the next one to rotate. You're sitting there staring for a minute too quickly, and it's just jumping too fast, and you don't really notice that it's distracting. The rest of these are just seconds on display as it rotates through the display. When you get down to the sections specific to those modules, you can enable or disable them with a true or false statement. The weather update interval is every 30 minutes, I think is what that is in seconds. That is so the current weather is relatively up to date. Other than that, the daily weather doesn't need to refresh that frequently, and the hourly weather doesn't need to refresh that frequently. It's just for the current weather to be relatively in sync to the outdoors. As a rule of thumb with all of these modules, you want to update them as little as possible. It's going to pull all day, every day, often, and we don't want to overwhelm these hosts that are providing this data. The weather, at least you have your own API key, and for the music, it's your own API key. But for things like stocks and stock news and crypto and sports, we want to be very cognizant of how many times we're hitting that API in any given period of time. So on that note, we have stocks and crypto updating once every 10 minutes. You can set your stock symbols here. Just respect the JSON formatting. I don't know how many is the maximum you have. You'll have to adjust the display duration to fit them all in, but you can add quite a few. And the stocks will cache the data outside of active stock trading hours so that we don't hit it too hard when the prices don't change. For crypto, you need to set the cryptocurrency, BTC, Bitcoin, ETH, Ethereum. You also need to add a -USD so you see what price it's loading in at. If you set this to euros or something, you'll need to change your display format icon here or currency symbol here as well. Stock news, we're updating every, every hour. That is so we have relatively fresh news throughout the day, but the stock news doesn't change that much. These are headlines. These are articles that are being written. You're going to probably see a couple of these repeat a few times. 1 hour is enough to see something happening that day, but not enough to be hammering the API source. The scroll speed is how fast it comes across the screen. The scroll delay is if you have some flicker with the text. I think this is a little bit of a leftover setting, but it's still in use. Just leave it alone. Max headlines per symbol is how many news article headlines to bring in for each stock symbol that you have. I have mine set to 1, so I bring in 7 stock symbols. And then each time that stock news comes around the rotation, we're seeing 2 headlines per rotation. I'll caveat that I'm having a couple of issues with this, and sometimes I see 3 or 4 per rotation. It kind of depends on how much time you have set to your stock news display duration and how long the headlines are. This is something I hope to make dynamic in the future, but it's a low priority for me and it's working well enough. If you really don't want to see news repeat, you're going to want to add more stock headlines per symbol, and it does shuffle and rotate the headlines randomly so that it's not the same pattern every time with the headlines. It tries to make it feel a little fresh by showing them in different orders and rotating through those headlines in different intervals. So it's not just one long chain of 7 news items, it's 2 at a time, and you'll get to see those change throughout the day. Calendar, this is using Google Calendar. You need to set the update interval. I have it at 1 hour. That's fine. I mean, I'm not adding a ton of calendar events on short notice to my display. This is things that have been on my calendar usually for weeks, and I just want to keep it relatively fresh at 1 hour per day is not too much. Credentials, JSON, and token pickle, you can leave alone. Those are defaults, and we'll auto-generate those later. You can set the max events to whatever you want. I've been using 3. I don't know how many it can really support. But if you want to pull in a bunch of birthdays, you can. And then the calendar, by default, I have birthdays because I believe that is a default calendar in Google Calendars, but you can change it to whatever you want. And I was joking with a friend that he could have a countdown of the Grateful Dead tour dates. And the way I would recommend doing that would to be create a Google Calendar for the Grateful Dead with all their tour dates. Bring that in here, add a calendar of Grateful Dead, and then enable it in your display, and you'll get to see those on your display as they come across. For the sports, they're all kind of structured very similarly. You have your enabled, which is generally, is this display on or off? So NHL right now, it's finals or semifinals. The Dallas Stars are going all the way. I want NHL on, but the NBA season is over. So I have that turned off because I don't want a blank screen saying no games found. Test mode is to configure the layout of the display. That's really just for me to change the font size, color, where the logos are positioned. You'll probably never use those, but it's there if you want to make some customizations and see what the layout would look like when a game is not active or when the season's not active. Update interval, again, 1 hour to pull in things like previous game, next game. We have those here as other intervals as well. Specifically, if you want to see the upcoming game quicker, I don't really know why you would, but again, we want to be very cognizant that we're not hitting the APIs too frequently. So once per hour, we can check and see what the score was for the game in the last 48 hours or when the next upcoming game is, with what day and what time and what teams are playing. The favorite teams are going to be your ESPN acronyms for the teams, and these need to match the logos set in the assets sports and then whatever sport folder. So for NHL, it's NHL logos. This is what it's looking for the sports data. You need to have it match. I think I have all the logo names correct, so you can choose from that list if you're not sure. You can add quite a few favorite teams. It'll rotate through those teams if they're on at the same time, and it'll rotate through those teams to tell you previous scores and upcoming games. Let's say you don't care about live games or recent or upcoming. You can individually tune those without turning the whole thing off and see just what you want to see with some granularity. NHL, I have 48 hours because they play very frequently. NBA, I think, was like every 3 days, so I had 72 hours. But NFL, I haven't been able to test because it hasn't been football season, but I have it at 7 days for last week and next week of the upcoming game. In very similar settings of update that information once per hour. And then while the game is active for all of these sports, I have it 15 seconds. 15 seconds to me is about the same delay as a TV. We're not hammering it too frequently during the game, but we're hitting it pretty hard and for a while. This is something we might need to tune as the season goes on. If college football, we're hitting for 9 hours straight every 15 seconds every Saturday, or during NFL, multiple nights a week, hitting it at 15-second intervals, it might be too fast. And realistically, 15 to 25 seconds, you might not notice as much. Just depends on how you're using this display. If it's in a rotation and you have a bunch of teams, you might not notice 25 seconds. But if it's the only display you have up and you only care about tracking that one sports team, you might want to keep it shorter to see those updates as soon as they happen. We have a bunch of sports here. We have hockey, basketball, football, college basketball, college baseball, MLB baseball. We have YouTube, which is tracking your subscribers and views if you have a YouTube channel. If you don't have a YouTube channel, you can disable this. Text display, I had a request for this from a friend that he wanted to type in a custom message and have it display on his LEDMatrix. So you can enable this, type what you want, set the font size. If you want it to scroll, if it's too long, you can do that. You can choose how fast it scrolls. You can choose the text color and choose the text background. And if you are scrolling it, you can choose the gap between the end of the word and the beginning of the next time it comes across. Back to sports, we have soccer on here. I'll be completely honest, I don't follow soccer. I don't know anything about soccer. I had to Google which leagues, and I tried to Google and download as many logos as I could. The leagues are all hit pretty hard for API calls. It loads each league individually through the API at ESPN. So if you're not tracking a team in one of these leagues, you're going to be much better off deleting that team or that league from your config. It's going to speed everything up in how fast it pulls in the data without having to iterate through each league looking for these teams. I have just Barcelona as a default to test with. I'm sure this is going to have some issues at some point. Please leave me a comment or open a GitHub issue during soccer season. I don't even know when that is, if you're having issues, and I'll try and look into it. Last but not least is music. This will show the album art, the song name, the album name, and the track progress on the display. It's really, really good with Spotify. It's so fast. You hit next song, it pops up immediately at a 1 second interval. YouTube Music Companion is not quite as fast. YouTube Music is much more reliable changing into that display. So if you're coming from Soccer Scoreboard to music or something, it'll pull the data correctly every time. But once it's on the display, I'm having a really hard time getting it to update in a reasonable time period. It's not been too bad for casual listening, but if you're skipping songs frequently, or if the song happens to change within the first few seconds of it coming on the display, it might be a little out of sync for the YouTube Music. It's something I'm working on. It's giving me a hard time, and I didn't want to get too caught up on that. And then you'll press Control X to exit. If you had made any changes, you type Y to save, enter to confirm that save. So now we've got all the configuration set up, and we've authenticated our Spotify and YouTube. We've got our Google Calendar set up, and everything should be connected. We've gone through and edited our config file, and I've gone through and turned everything on for the sake of demonstration here. But before we run the display for the first time, we need to change some file permissions of the home folder for LEDPie. If you named it something else, you would change LEDPie to the name of your Raspberry Pi user. And this will help the script be able to edit files. And there's going to be no feedback there. But now we can take sudo python3 display controller pi, paste that, and there's going to be no output from that command. We're going to cd into LEDMatrix. And then we can take our command finally to manually run the project. And it's going to launch the display. And while it's getting ready, we will have some debug messaging about the fonts being loaded and the different areas of the display being loaded, such as your city module loading for weather, fallback time zones, and then module by module, it's going to load the stock news, stocks, sports, and you can see how the API calls are being implemented. And you can kind of see when we get to the soccer section why we want to be careful about how many teams we have, because it's going to pull a lot of data for every team, for every league. So you want to set your favorites, definitely. If you leave it blank, it should pull the whole league, but that's going to be just too much. And we can see here it's pulling the data for multiple days for different leagues. If you don't care about some of these leagues, you can dramatically reduce your API calls by ignoring some of those. We can also see how it's building the cache for some of these games as well. For NFL, we have these schedules for upcoming games set, and same for NCAA football. We know that first game, it's just not within our time frame to display it on the display yet. But it's going to process through all of the games for all of the sports. And this is why I highly recommend that you disable various sports leagues when it's out of season. If I wasn't filming this as a demonstration, I would not have any of the football enabled. I would not have soccer enabled. I would not have any basketball enabled because it just really slows down the startup and makes a lot more ESPN API calls. I'm not really sure how it's going to process lots of calls for a long time. They might end up blocking me or something that I'm worried about. So we're going to try and reduce that. As we go through, we can see the weather. It gets a weather code from our API at OpenWeatherMap, codes such as 03D. That's cloudy for the daytime, and it's going to assign that to an image. We have all of that in our assets folder if you were to change some of the icons. Here we can see for our stock manager, we're getting 120 frames per second as it scrolls through, and I'm recording it on my camera and I'll put it on the screen here so you can see as we go through this. Stock news, it found 7 items and it's going to generate a headline for 2, and it's going to scroll that. And once that has scrolled those 2 news headlines, it's going to grab the next 2 right there, generating image for 2 more to pull across. So if you want to dial that in, you can do so. Switching to the Google Calendar, we can see an event for all day coming up later this week. And it looks like the camera is kind of like pulsing with the pixels. It's just an effect of the camera to the naked eye. It looks solid and fine. Switching to YouTube is my YouTube channel. We went through the instructions on how to set that up and find your channel ID. So if you wanted to put yours on here or someone else's, you might be able to see theirs, but it needs your API. And here for YouTube, we went and set up for my channel for the subscribers. And then we have our message for the text display. Don't forget to subscribe. This has been a long video. Hopefully you've appreciated this. This would be the best way to help me out if you like it. And then for the music manager, nothing is playing. So I'll go to Spotify, which I don't usually use. And I'm just going to hit play. Ooh, let's mute it. And we can see it pops up very, very quickly with the album name and art. And if I hit next, it updates very, very quickly as well. Going into sports, we've got a recent NHL game, Dallas versus the Oilers. Dallas lost, but this one, I got the logos oversized and positioned, and it looks pretty good. The font for the next game, where it's a little larger and overlaps the logos, has a 1-pixel black outline that chews into the logo a little bit, but it makes it a lot easier to read. NBA, there's no recent games to display, so it's not going to refresh the screen. It's going to keep the previous display longer than intended, and that's because there's nothing to display. That's because the NBA season's been over for quite some time now. Same for NBA upcoming, didn't refresh the display because there's no data to show. So it ignores that. For baseball, looks like we have a live baseball game happening. So that will take over the display, and I didn't realize that was starting right now. So that's going to kind of mess up the rest of our display here because it's going to stay on the baseball screen. Didn't quite get through everything I wanted to show, but we got most of it. I think from here on, it's just different sports. But again, because we have a live game, the Rays are playing. The Rays are going to stay on the display until the game is over. And when the Texas Rangers come on and play in an hour, it'll rotate between those 2 games. To run this LEDMatrix automatically when the Raspberry Pi turns on or has power without you having to SSH into it to turn it on, we have a script to do that using systemd, which will launch the script as soon as it starts. And we have a few steps here to install it. The first is going to make the script executable. And then the second is going to run the install service. And it gives us some commands here. When the Raspberry Pi starts, it automatically loads. And right now, as I executed that, it started the process. If you want to disable the Autostart, you can use these commands here. You really shouldn't have to mess with it once you run the install service script. If you need to execute the stop display, which is what I would recommend, and there's a reboot otherwise, you will need to make it executable with chmod plus X. So go ahead and knock that out so you don't have to worry about it in the future. And you're good to go. This should run great. Hopefully this hasn't been too painful to follow along. I'm really proud of this project. It's something I've worked on for a while, and I can't wait to hear what you think about it. Hopefully this has been helpful for you. I think this is super cool. This has been a white whale for me for a little while trying to get this made. I have some history on my write-up. We've got a long write-up here of everything you need to know about how to set this up, what to buy, and how to do it, just like I did. If you have any questions, please leave a comment. Let me know. Jump in my Discord. I'm happy to talk to you about it or field any potential feature updates that you might recommend. And we also have a GitHub here with all the files where I'll be keeping all the updates. I've made a few commits since the release, so we'll release to 1.0.1. And hopefully I can get some more features on here soon. Next up on my list is MQTT. I want to integrate this with Home Assistant somehow, just not quite sure how to do that yet. If you know how to code or you're looking at this and thinking I did a poor job, please make some changes and make some pull requests. I've never done a pull request before, but I'm willing to learn if you're willing to suffer with me. Thanks for watching. And if you have any questions, please reach out.